Hello, my name is Austin Beecham and I'm a sales engineer at Bytecode. I'll be walking you through a real-world example of how Looker and BigQuery machine learning work together to help build a customer retention model. In this video, you can expect to see BigQuery machine learning helping resolve customer retention by fully analyzing the problem, easily incorporated to predict customer return, using the prediction to automatically send coupons to customers, and tracking progress of the campaign. Our analysis starts with a brick-and-mortar retail chain struggling to drive customer loyalty. After reviewing 2 years of transactional data from the 7 stores, it was clear that the surest way to drive up revenue was to get customers to come back to the store after their first purchase. Of the 42,000 customers, 25,300 are one-time purchasers. If only a third of those customers returned, it could drive up yearly revenues drastically. When asking the president of the company, he believed customers would return to the store primarily if they lived locally and they received a good discount on their first purchase. Other additional factors he thought would be which store they shopped, the demographic they were shopping for in the store, the amount of items they purchased, and the total amount spent. When analyzing these factors individually across one-time and returning customers, we found only a slight correlation. This makes for a great scenario to use machine learning models because it will identify patterns in the data that are not obvious, just like in this case. However, these factors can be assessed collectively across more than 42,000 first-time transactions to increase correlation. Thanks, BQML. In order to predict whether a customer would or would not return to the store within 180 days of their first purchase, we chose a logistic regression model. This retail store primarily sold shoes, so we felt 180 days or 6 months was a good estimate for concluding a customer is a one-time customer. Before we create our model, we need to make sure our data is properly prepared. First, we cleaned any bad data. In our case, the discount was occasionally improperly inputted by employees, so we created BQML dimensions that fixed our problem. Next, we binned our values to help normalize the data. This makes it easier for the model to learn customer return patterns. Following, we created our customer's first transaction view and divided the customers into 2 groups. The historic group, customers who have already been customers for 180 days, and the predicting group, customers who have not been customers for 180 days. For those historic customers or customers we know if they've returned to the store or not, we will use them to train and evaluate the model. Best practice is to train using 80% and evaluate using the last 20%. Everyone else that hasn't been a customer for 180 days, that will be the group we predict. After running the model through the training and evaluation, the model provided the following information. The most correlated factors were which store they visited and whether they lived locally. Interestingly enough, the discount they received was near the last. Knowing that discounts did not necessarily drive loyalty was really important for the president of the company. The model was not highly precise at 58% accuracy, but fairly confident at 73% for the highest prediction. In the evaluation stage, it had a 50% precision and a 31% recall. So it handles false positives better than false negatives, which is what we don't want from our model. We need to keep working with the model to try to bring down false negatives, as we don't want to possibly shun or possibly avoid customers that are predicted not to come back but do come back. Now that the model is set up to predict, we can now automate the analysis of all new customers to the store each day. Using a look and schedule, we can create a process where we send new customers who are most likely to return to the store a coupon to incentivize them to return. In addition, the training model is persisted, so it runs each day, retraining the model for more accurate predictions as conditions change. Then, the campaign dashboard analyzes how the overall effort is going. In the funnel chart, we can see 2,930 total customers have been sent an email. And of those customers, 932 customers have returned. We can also see how many false negatives have been identified, which are the customers not predicted to return, but do return. This entire process has been built and automated within Looker. From the initial analysis of the customer base, to correlating return factors, to the creation, training, and evaluation of the machine learning model, to automation of analyzing new customers each day and sending out email incentives, to tracking and analyzing the overall performance of the campaign. This is some powerful stuff. Thank you for your time today, and I hope this has been helpful. If you're curious about how we created the code and the behind the scenes in a deeper dive, don't forget to check out our BQML Part 2. Thanks.